I'm Anil Kumar, and in this video we'll try to understand how to sketch graphs for reciprocal trigonometric functions. As an example, I have here a secondary trigonometric ratio secant x. Sketch the graph of y equals to secant x minus 1 state period for the function. Now this is transformed, it is moved 1 unit vertically down. To sketch the graph of y equals to secant minus x, we should start with the primary trigonometric ratio cos x, correct? So let me rewrite this function. We'll say y equals to secant x minus 1 is equals to 1 over cos x minus 1. So we will actually sketch cos x first, then do reciprocal of that, and then translate the whole thing 1 unit down. So these are the steps to be followed. Now, as I normally do, we'll just sketch a sine wave to start with, right? So let me sketch a sine wave. So I'm not using any particular scale here, but we'll soon put all the things in perspective, right? So that is a sine wave for us. Now, to make it cosine wave, it has to start with the maximum. That is what makes it cosine wave, right? So let's draw the y-axis from maximum itself. Okay, so that becomes the y-axis, and the x-axis will go right through symmetry for the graph. This is axis of symmetry for us, right? So there you have cos x. Now for cos x, as you know, it starts with maximum value of 1, so this is 1 for us, and the minimum is minus 1, right? Time period for cos x is 2 pi, perfect. So now we can say the half of 2 pi is pi, half of that is pi by 2. 1 pi by 2, 2 pi by 2, and this is 3 pi by 2 for us, correct? So like this it continues. This is of course minus pi by 2, and 2 pi by 2 I could say as, when you say 3 pi by 2 is 4 pi by 2. So we could write here 5 pi by 2. Correct? So that's how we can count and continue. So that is the graph for cos x. So this we have here is cos x, right? So first in this color we have cos x. Now we will do reciprocal of this function so that we could get cosecant x. Now when you do reciprocal, then the x-intercepts will lead to vertical asymptotes. So we'll just sketch vertical asymptotes here, right? So it's not so difficult. I mean, once you understand the concept, it should not be so difficult. When you do it on a graph paper, properly writing down all the units, you'll get a very good, accurate result. But the steps are same, correct? So draw all your vertical asymptotes, which corresponds to 2n plus 1 pi by 2, right? It's the odd values of pi by 2, correct? Zeros of cos x will become vertical asymptotes for secant x. There we go. Now the second step is to do reciprocal of it. So reciprocal of 1 is 1, right? As it decreases, the reciprocal increases. So you have this as your kind of reciprocal. Do you see that? So that is your secant x, okay? I've taken a light color this time purposely, since we are actually interested in a transformed function, which is secant. This is secant x for us, correct? Okay, now we need to translate it 1 unit down, right? So this is our 1 unit. So every point gets translated 1 unit down. Perfect. So this part which started with 1 will now get 1 unit down. So we will have that as our final function, and this is secant x minus 1. Do you see? So bring down each unit, each part of secant x 1 unit, so that you get y equals to secant x minus 1. Do you see that? So this negative part, let us say this is minus 2 for me, right? Let's say this is minus 2, will be kind of here, okay? Now since I'm running out of page, I made it shorter. but you get an idea, right? So that is the function which we have as secant x, right? So let me write few characteristics for this. What is the domain of this function? First, let me state the period. Period is pi for it, since this wave, do you see, repeats, do you see, after pi, correct? So that is your function, for example, right? This is one cycle and it repeats thereafter, correct? So the time period is pi for you. The domain for the secant x will be x belongs to real numbers. However, x is not equal to these odd multiples of pi by 2, right? So we can say 2k or 2n, normally we use 2k plus 1 times pi by 2. You could use minus 1 or plus 1. Doesn't really matter. Both gives you the same thing, where k belongs to integers, right? So for integers, you can write I or z. Okay. So that becomes the domain. It's very important to write, right? And however, the range is what? Range is y belongs to real numbers. But you'll see that y is either greater than equal to 0 in this case, or it is less than equals to minus 2. So that becomes your range for the function, right? And similarly, you can write down other characteristics. When is the function positive? When is the function negative? When is the function decreasing? When is the function increasing, right? So likewise, you can write all of the characteristics. This is a very important question from test point of view. So have a good look at it and write all of the characteristics of this function secant x minus 1 to prepare yourself for the test, right? So namely, I would like you to write down when the function f of x is greater than 0, when the function f of x is less than 0, when the function f of x is increasing, and when is it decreasing. That will be an exercise for you to do, and I hope that will prepare you for your test. Thank you and all the best.